Stop watching, my neck is fuzzy. Make big deposits, my gloss is popping. You like my hair? She thinks, just bought it. I see it.
Hi guys, it's Eliza. For today's vlog, I am going to discuss about the composition of functions. But before that, let's define what is function and relations. Relations versus functions. All functions are relations, but not all relations are functions. What can you say about that statement? Is it true or false? Let's prove your claim. An ordered pair is a set of two real numbers, x and y, on the rectangular coordinate system. The first real number, x, is the x coordinate and the second y coordinate. The order of the x and y coordinates affects the meaning of the relation. A relation is any set of one or more ordered pairs. Relations are expressed using table of values, graphs, and equations. However, a function is a relation wherein no two ordered pairs have the same x coordinates. Each x coordinate is paired to one and only one y coordinate. This makes every function a relation, but not all relations are functions. Functions are represented by y is equal to f of x, and read as y is a function of x. Therefore, this statement, all functions are relations, but not all relations are functions, is true. I hope your hypothesis is correct. Start with evaluating a function. Evaluating a function means finding its y coordinate given an x coordinate. Here, x coordinate is the independent variable and y coordinate is the dependent variable. To evaluate a function, substitute the given x coordinate on the equation that represents the function. Then, simplify the terms. Functions represented by more than one equation are evaluated in the same way. Let me give you an example. Let's find the value of f of x wherein the x is equal to -5. In f of x is equal to x squared minus 1, substitute -5 in place of x. Then perform the operations. Therefore, the final answer is 24. Another example. X is equal to a plus 3. In f of x is equal to x squared minus 1, substitute a plus 3 in place of x. Since the value of x is a binomial and it must be squared, you expand the binomial term and multiply using FOIL method. FOIL method is multiplying the first terms, outer terms, inner terms, and last terms of the expansion. Then perform the operations. Therefore, the final answer is a squared plus 6b plus 8. Composition of functions. Composition of functions is another way in which functions can be combined. It uses the output of one function's g as the input for second function's f. How are composition of function represented? This is represented by f of g of x is equal to f of g of x. The expression f of g of x is read as f circle g of x and f of g of x as f of g of x. This operation is not commutative. Thus, f of g of x is not equal to g of f of x.
For example, f of x is equal to 7x minus 4. Then g of x is equal to x squared minus 2. What is f of g of x? Take note that f times g is different from f of g. When we say closed circle, it is the multiplication. But if you see a open circle, it is the composition of function. One function is inside of another. G is inside of f. So, this is equal to f of g of x. Let's find for f of g, where g of x is inside of f of x. So, we're going to replace all the x's of f with x squared minus 3. So, f of g of x is equal to 7 times x squared minus 2 minus 4. Let's distribute 7. So it will be 7x squared minus 14 minus 4. Let's simplify. So it will be 7x squared minus 18. Therefore, f of g is equal to 7x squared minus 18. Another example. What if it's the value of g of f? Let's find the value of g of f. So this time, f is inside of g. Let's replace the value of f with 7x minus 4 instead of x squared minus 2. So it's 7x minus 4 squared minus 2. Let's solve for the square of 7x minus 4. 7x minus 4 times 7x minus 4. So it will be 49x squared minus 28x minus 28x plus 16 minus 2. Let's combine like terms. Negative 28x minus 28x is equal to negative 56x. 16 minus 2 is equal to 14. So it will be 49x squared minus 56x plus 14. Therefore, g of f is equal to 49x squared minus 56x plus 14.